Hi, everybody. Today, what we're going to get into is introducing a new way to write things and a new way to express things. And we're going to talk specifically about function notation. So, we're going to have a little bit of a conversation with respect to functions, and now we're going to just talk about the notation that we're going to begin to use to express those ideas. So, what you see on your screen in front of you, this will line up with your lesson handout. Again, don't blindly just fill in the blanks. The top line just gives us a little bit of background. Really what we're looking at is a way to communicate about functions. The important parts are quickly and with ease. However, in order to communicate properly and make it be easy, make it be quick, we all have to talk the same language so that we're all understood. So what we're going to do today is introduce that language. The second part there talks about that we will be comparing or changing. If you want to look at it, we'll be manipulating. We will be affecting functions. And so we have to have a way to name them. I couldn't be kind of more explicit or maybe direct if I was to say naming our functions is going to be one of the keys to this new notation. So take a look in the blank space that you have below that, and you'll notice that I just put up our good old grade 9 function. There's our line, y equals 2x plus 1. What I have to the right of that, I'd like you to get down, because that starts to talk about maybe how or why we're able to label what we will with what we do. So what you see in red then, that would be us kind of speaking about what we saw in purple. That we could say that y is a function of x. And just notice that what we see up there is that our y function is made up of x's. And it is a function. So I could read in red that y is a function of x, and I could express that in notation as y equals f, and then in brackets, our x. The way we would read that as y equals f, and in between that, we know multiplication, at least it kind of looks that way, of x. The important part for us, it's not multiplication between the f and the x. And I know that we've spent a lot of years drilling into you that if I don't see anything between those variables, that means multiply. We have to be very clear here that that is not f times x, but that is f of x. And you can see it in red. Y is a function of x. And so if I was to take my red line with the notation in it, y equals f of x, well, if y is equal to f of x, then I can replace my y with f of x, and I come in on that new purple. So I could express it then as f of x equals 2x plus 1. Now, I just want to take a moment on that last purple line just to break down a couple things in it. The first thing that we should notice, what that left side says is I have a function and it is called f. That function is made up of x's. And now you look on the right side of the equal sign, and 2x plus 1, if I was to graph that with an output variable like y, we would notice that that would be a function. So what that entire purple line says is I have a function made up of x's, and this is the equation to it. Now look at the last line where we have, does it have to be f of x? No. We're going to see very common labels, such as g of x, h of x. In fact, that h of x function would be something that we would see to be very common, maybe coming out of our grade 10 class when we spent all that time dealing with parabolas. The only thing that I want to kind of shy you away from is using the name x of x, because that terminology starts to get really confusing. Now, was that a function made up of x's that you chose to call x? Or was that x times, I'm hoping that we can see, that last one's pretty confusing. But for us to have a function called g or a function called h and so on, that's going to be pretty common. Okay, that's it for some overlying general theory. I think what we're going to learn today is going to be through the process of doing. So what I want to do is I want to jump into the rest of this page. You see that next section just asks you to name the function using function notation. So we could go through in question A, and we could see that our function is made up of x's. And so my function notation must have x's to it. Now, I get to pick what my name might be, and maybe since this is the first one, I play it really safe, and I just call it my generic f. Now, I need my equation. So 3x squared becomes the expression that represents my function. That function I've chosen to call f, and it is made up of x's. Everything in that line has to be there, with the exception of f. You could have chosen a different label if you like, but the rest of the purple had to be matching. Okay, let's jump and take a look at b. Your function in b should look very familiar. And as I mentioned earlier, there's your good old parabola. That would be us, dealing with throwing a ball off of a roof or a balcony and it falls to the ground. You can see your variables in the expression. We have h and we have t. So maybe that h might represent something like height. That t might represent something like time. Very common function for us. Okay, we're going to name that function using function notation. So maybe I like the fact that it's a height function. So I like calling it h. No worries, then call it h. So maybe we call it h. And it has this equation to it. Okay, I want you to think about what has to be in the brackets. And I'm hoping that we came to that conclusion. Notice I can't call it h of x. I can't call it f of x because there are no x's in that function. It is not a function of x. It's a function of t. So same thing as previous. The only thing that could have been different was what we called the function. Everything else in that equation had to match up. T is my independent variable. So it is a function of t, and there was the expression that gave it to me. Okay, I want everybody to just take a shot at C. Okay, go ahead and pause the video now. Okay, so we're back. So the only thing that needed to make sure that we had was an a cubed and an a. And I'm hoping that everybody had in brackets your a because it's a function of a. And who cares what we called it? I'm going to bet and say nobody called it k of a. So I just chose to pick k. Again, you could have chosen f. We need to know as well, like, hey, that k was uppercase. I know you didn't know it, but maybe we had an idea in our mind that all of our functions had to be lowercase variables. No, there's no problem calling it a b of a function and using an uppercase b. We have all of those as options as well. So I'm hoping that you took a look at that, and now we're at the very least kind of comfortable with naming functions and seeing the parts that have to be in there and then the parts that we get to choose, perhaps. Okay, let's jump in and actually start using this function notation.